Welcome to the Explainer. Jay, we're going to break down a piece of tech that sounds a little bit like science fiction. It takes the weeks-long, painful process of building industrial control dashboards and shrinks it all the way down to the time it takes to make a cup of coffee.
Okay, so let's just dive right in. What we're looking at here isn't just a small improvement. It's a fundamental shift in how the screens that run our factories are actually made. What used to be this long, tedious coding project, well, it's now becoming this unbelievably fast, AI-driven design process.
But to really get why this new way is such a game changer, we have to appreciate the problem in the first place. I'm talking about the daily headache that factory managers and system integrators have been putting up with for years.
Building these SCADA dashboards manually is a huge bottleneck. It means writing really complex code from scratch, painstakingly lining up every single button and chart pixel by pixel. And you know what? Any small change from the customer can send you right back to the drawing board. It's slow, it's expensive, and honestly, it's just frustrating for everyone.
Now this is great. This slide has this brutally honest quote from the source material, and it really hits the nail on the head. It points to this classic conflict. These dashboards are built by brilliant engineers who are focused on function, not form. And the final look? Well, let's just say it often shows.
So, how do we fix that, right? How do you get world-class function and world-class design in a tiny fraction of the time? Let's get to the demo and see how this thing builds an entirely new reality. This is where it all begins. And instead of opening up a code editor and staring at a blank screen, the developer starts with something super simple, a hand-drawn sketch. We're talking a basic layout of where they want the charts and data to go. That's it.
And this just perfectly illustrates the second piece of the puzzle. This is the exact text prompt they feed to the AI. It's not code, it's just a simple conversational request that kicks the entire design process into gear. It's amazing.
So the AI takes that sketch and that prompt and it gets to work. The entire process from start to finish takes just 90 seconds. Yep, a minute and a half.
And boom, here's the output. In just 90 seconds, you get a complete, professionally designed industrial dashboard. The layout is clean, the components look sharp, and it's all ready for the next crucial step.
But what's actually going on in those 90 seconds? It's really important to understand this isn't just generating a static picture like Midjourney or something. No, it's way more sophisticated than that.
The source material describes the AI's role perfectly. It's not an artist, it's a senior front-end dashboard architect. It actually understands layouts, it knows what industrial components are, it gets design principles, and then it translates all of that into a structured, functional interface.
Okay, so this is the crucial point. The result is not a flat JPEG. Every single chart, every gauge, every number and label you see on that screen is a separate individual object that you can move around, resize, and edit.
And this whole thing is built using standard modern web technologies. What that means is it's not locked into some old proprietary clunky system. It's accessible on any modern web browser, and you can go in and fine-tune the properties of every single component.
Now, a beautiful dashboard is pretty worthless if it doesn't show real information, right? So let's see how this brand new interface gets hooked up to the live data coming from the factory floor, from the PLCs, those little computers that run all the machines.
Connecting a visual part to a live data source is unbelievably simple. You just click the component on the screen, you pick the data variable you want, like a pressure sensor reading from a machine, and you bind them together. Done! No complex coding needed at all.
And what's really cool is that this process scales up beautifully. So instead of connecting hundreds of data points one by one, which is notoriously boring and tedious, the AI can help automate that entire mapping process. We're talking about saving countless hours of manual work.
So, what does all this speed and flexibility actually mean for a business? This is where the technology stops being a cool demo and starts being a real strategic game changer for smart manufacturing.
I mean, the most dramatic benefit is right here on this chart. We're looking at a massive compression of the development cycle. Projects that were measured in weeks are now measured in minutes. That is literally the definition of agile development.
This kind of speed just unlocks huge strategic advantages. Think about it. You can show a client a working prototype in the very first meeting. You can make changes based on their feedback in real time. It empowers engineers who aren't front-end web experts. And this is important. For really complex business logic, you can still drop in your own custom C# scripts to maintain full control.
So the ultimate takeaway here is this. We're watching this shift from a world where building industrial interfaces was a slow, code-heavy chore to a world where it's a fast conversational design process. It's completely bridging the gap between an idea and a working tool.
And that leaves us with a final, kind of provocative thought. If this major bottleneck in visualization is now potentially solved, where does the smart factory industry need to focus its energy next to unlock that next level of efficiency?
Traditional industrial configuration development, still manually dragging and debugging repeatedly. Now just describe the requirements in one sentence. AI automatically generates professional-grade SCADA pages. No code required. No design foundation required. Minutes to deliver work that would otherwise take days. From equipment monitoring to production line dashboards. From energy management to failure warning. AI SCADA can flexibly match the whole scene. Accurately respond to your every need. So we're going to run through some real-life scenarios. For example, help me generate a kiln monitoring screen. Kiln temperature changes need to generate line graphs. Kiln numbers and monitoring cycles generate data. For example, I want a monitoring interface for breaking and unpacking. A visual representation of the machining process is required. Please help me design an injection molding machine monitoring page. Light style. Use a line chart for the core location. Real-time display of injection pressure and clamping force curves. Also include a health assessment of the current mold. If you have detailed SCADA requirements, you can also send it all. For example, the factory has 8 propylene polymerization reactors. When raw material purity and ambient temperature change, manual adjustment of parameters, it is difficult to balance meeting production capacity standards and minimizing energy consumption. For example, when the purity of the raw materials is high, mixing speed can be reduced, but that wastes a lot of electricity. So I need your help. Design a real-time control dashboard. More AI scenarios are waiting for you to create.